We're going to work one of the practice problems for one-dimensional arrays. This practice problem is on the Fibonacci sequence. So the numbers are 0, 1, 1, 2, 3, 5. You can see the list here. The number is the sum of the two preceding numbers. So the first two numbers are defined. Fibonacci 0 is 0, Fibonacci 1 is 1. But now this one is the sum of 0 plus 1. So we can see that 1 equals 0 plus 1. And 2, this one, is the sum of 1 plus 1. Right? And 3, Fibonacci 3 here, is the sum of 2 plus 1. So we're going to then use a loop to walk through the numbers, create the Fibonacci numbers, and we're just going to store them in an array. So this is just an exercise where we're going to use arrays. So write a program fragment. Sorry, we'll write the whole program, just not the fragment. We're going to declare an array named Fibonacci of length 40. We're going to fill the array with the first 40 Fibonacci numbers. Right? So you're given a hint to fill in the first two numbers individually, and then use a loop to compute the remaining numbers. So let's just go ahead and make this a type int. Right? All right, and we'll call it Fibonacci. We're told to make it 40 long. All right, so there's our data type, our name, our size, and now we can just use an initializer list if we want, which will then, we said the first number is 0, the next number is 1. And we learned if the initializer list is too short, it will store zeros in the rest of our array. Just go ahead and save this much. We just build this. We'll get some warnings about unused variables. But let's just run the debugger. Run the cursor. Right. And now if we open up our array here, we can see that the first two we have 0 and we have 1, and then it says the second one and the rest, it says 0 just repeats 38 times. But we can see it did go ahead and 0 fill the rest of the array. We weren't as concerned about that as we were of initializing these first two. We stop the debugger. So now let's go on. So now we want to compute the next 38 Fibonacci numbers. So let's create for int I. Let's set I equal to 2 because we've already stored one number in index location 0, another one in index location 1. So we'll start at index location 2. As long as I is less than 40, plus I, right? And we said then that Fibonacci, right, in index I, is simply going to be equal to the previous two. So that would be Fibonacci in index I minus 1 plus Fibonacci at index I minus 2. Right? And let's look at our array boundaries. When I starts off as 2, well, 2 minus 1, that will be index 1, so we'll go get that number. And then when I starts off at 2, 2 minus 2 will be index 0, it will get that number. So we won't have a negative array index. We shouldn't exceed our array indices because I will stop when it's less than 40, so index 39 will be the last one that we want to fill in. We can do a run to cursor here, right, and step through this. Nope. What did I do? Oh, comma instead of a semicolon. Let's try that again. All right, so run to cursor, right? We can see there our first two array elements are filled in. I has garbage in it, but now when I say next line, I becomes 2. 2 is less than 40, so I becomes 2. It does the test, passes the test, steps in here. So we'll say, we'll store in index 2 the sum of what's in index 1 and index 0. So next line. All right, so now we can see at index 2, we add 1 plus 0. Index 3, we get 2, which is 1 plus 1. At index 4, we get 3. That was the 2 plus the 1. Right? And if we go all the way through, we'll see this keeps repeating. At index 5, we'll go get the 3 and the 2. Right? And that will be 5. At index 6, we'll get 5. It'll take 5 plus 3, right? And store 8. right? And we can just let this run. If I go down here and say run to cursor, it will finish the loop, right? We can see these numbers suddenly start getting really big. But we then filled in the first 40 Fibonacci numbers just by using a loop, practicing our array notation. It's a good exercise to work with arrays. Now, here's the other thing. Notice I hard-coded the 40 in here. We could have done something like const int a size for array size, or maybe length. I could have set that equal to 40, and everywhere I used 40, I could change that to a size, and then I can change this comparison to a size, which will still work if I do a run to cursor, so it'll do another build. And, oh, that won't still work. I had not gotten around to discussing this yet. Right? This comes in the later part of the lecture. If you're watching this after the first lecture on 1D arrays, this is called actually a variable sized array list, and it cannot be initialized. Now, will it let me do this? Define a size 40. If I get rid of this, right? And now, oh, I need to stop that debugger. I compile this and build. Now it's happy because this, whenever you use a preprocessor directive, this just directly substitutes the value here in here. But when we were trying to use that variable we declared, it won't let us use the initializer list. These are just some of the, I will call them fun little things with C. They're things if you don't work with all the time, like I did that without thinking about it, right? So variable length array, meaning we use a variable, even though we use the word const with it, it wouldn't allow us to do that. All right. So end of the Fibonacci exercise. Hope I didn't confuse you with that.